Hi everybody, this video is going to be really our second part to parallel and perpendicular lines. Our first video talks more about how can I determine if two given equations are parallel, perpendicular, or neither. This video is going to focus more on how do we write equations for parallel and perpendicular lines. So the most important thing that you really had to remember today is that parallel equations, okay, or equations for parallel lines must have the same slopes, and I would add that they also need to have different y-intercepts. And perpendicular equations need to have what we called opposite reciprocal slopes, meaning we changed the sign and we flipped the fraction. So we're going to get a little more specific today, and instead of just determining if two lines are parallel or perpendicular, we're going to be writing equations given some specific information. So we're going to write some parallel lines, or equations for parallel lines to start here. Now, example 1 says we need to write an equation for the line that passes through a specific point. It needs to pass through the point -2, 7. And the line that we're writing an equation for needs to be parallel to the equation given by y equals -4x plus 1. Now, let's think about what that means. If I need a line that's parallel to this one, that means my line needs to have the same slope as y equals -4x plus 1. So if that line has a slope of -4, the line I'm writing an equation for needs to have that same slope. So it really boils down to we need to write an equation that goes through this point, x1, y1, with a slope of -4. Well, that's what our point slope form is for. We can do y minus y1 equals m times x minus x1. So let's do it. We've got y minus 7 equal to -4 times x minus a -2. So let's change this to an x plus 2, since we have a minus a negative here. We'll distribute. And then add 7 to each side. So we would get y equals -4x minus 1. So this is a line that is parallel to the one that we were given. And we can tell because they have the same slope of -4, but different y-intercepts. So you can see it's a little bit more work now. We have to actually write an equation given some specific information. Now, example 2 is the same. We have a specific point that our line needs to go through. It needs to go through the point 3, -1. But the problem is we can't as easily find our slope. We know that our line needs to be parallel to this line, but I have no idea what the slope of that line is. So we need to do a little bit of work before we get to this given equation for y so we can identify the slope. So we would start by subtracting x from each side, and then divide by 3. So this is really a -1x. So if I divide by -3, I get a positive 1/3 x. And then minus 3. So now we can see this equation has a slope of 1/3. So our equation should also have a slope of 1/3. So now we use our point slope formula. Y minus y1 equals the slope times x minus x1. So let's change this to y plus 1 since we're subtracting a negative. Let's distribute our slope of 1/3. And then to get y by itself, we would subtract 1 from each side. So when we're finished, our equation is y equals 1/3 x minus 2. And again, we can verify that our two equations are parallel because they have the same slope of 1/3 and different y-intercepts. So this is for parallel lines. Now we can do the same thing for perpendicular lines. The difference is we just aren't using a same slope anymore. We're using an opposite reciprocal slope. So example 3, we're given a specific point that our line needs to go through. But now we want an equation for a line that's perpendicular to this line here. Now, this line has a slope of 2. The opposite reciprocal of 2 over 1 would be negative 1 over 2. So our slope that we're going to use is negative 1/2. So here's my x1, y1. Here's my slope, and we use point slope form to write our equation. So we get y minus y1 is equal to the slope times x minus x1. We distribute our negative 1/2. We add 3 to both sides. And here's our final equation. And we can verify that this is a perpendicular line because the slopes are negative, or I'm sorry, not negative, but opposite reciprocals. One is 2 over 1, the other is negative 1 over 2. Now the last one here, we're given our specific point again of negative 5, 1, but I don't immediately know the slope of this other line, and it needs to be, excuse the misspelling here, but it needs to be perpendicular to this equation. I need to know the slope of that equation, so I solve for y. We subtract 5x from both sides. So I can see that the slope of my given equation is negative 5/3, so I need to use an opposite reciprocal slope of positive 3/5. So now I have everything I need to know. I have my x1, y1, I have my slope, and I can use my point slope form. So y minus y1 equals the slope times x minus x1. Since we have that minus negative 5, I'm going to rewrite that as x plus 5. And now we're going to distribute our slope and get y by itself. I hope this video helped. Please pause, rewatch, rewind, and if you have questions, please let me know. Have a great day.